Okay, next up, dilutions. Again, a subject of your lab, either tomorrow or Thursday, dilutions. Dilutions, we'll be working with the dilution formula, which looks like this. M1V1 is equal to M2V2. I prefer a more general dilution formula, which reads like this. C1V1 is equal to C2V2. Now, of course, if we work with this version, M stands for molarity. If we work with this version right here, C stands for concentration. And so it's a more general form because most concentration units we can work with this dilution formula. V would stand for volume. A subscript of 1 stands for before dilution, which means a subscript of 2 would stand for after dilution. So then to work with the dilution formula, we have a couple of examples here. So for this first one, let's go ahead and try this out. We'd like to know what is the concentration of a solution prepared by diluting 10.00 milliliters of a 20.0% mass volume solution of glucose to a final volume of 200.0 milliliters. So because this is a dilution problem, we'll start with our dilution formula. C1 times V1 is equal to C2 times V2. And then we ask ourselves, what is it we're looking for in this problem? What are we looking for?
Concentration.
Concentration. Specifically, are we looking for the concentration before it gets diluted or after?
Yeah.
After. We want to know what is C2. Then, if this is C2, that must mean that this one here is C1. And the 10.0 milliliters must be V1. The 200 milliliters must be V2. Now, before you start assigning things, if you're totally unsure, you need to remember these things. First of all, when you dilute something, you start with the concentration that is large, and you wind up with a small concentration. So again, if you dilute something, concentration is big, you wind up with a small concentration. The volume starts really small and winds up big. Because again, if you dilute it, you're adding water. So for this one here, we want to find what is C2. So to get C2 by itself, we have to take each side and
divide by V2.
Divide by V2. So once we divide by V2, what we find is C2 is equal to C1 times V1 all over V2. We can then plug in our values. To plug in the values, C1 is 20.0% M over V, glucose. And then we're going to multiply that by V1, which is 10.00 milliliters. And then we're going to divide that by V2, which we said is 200.0 milliliters. So once we have these, what do we do with our units? Cancel out. What cancels? Milliliters go away. And so then we can take the numbers and multiply them together. And we can do this one in our heads. We take 20 times 10, which is going to give us 200. We take 200 divided by 200 and we get 1. And so 200 divided by 200 again is 1. How many significant figures should that answer have?
3.
3. And then we carry down the units, which would be percent mass volume C6H12O6. And that there would be the answer. So any questions on this one here, David?
Isn't 20% actually 0.2?
It is, but then if you change it to 0.2, you take 0.2 times 10, which is going to give you 2, and divide it by 200, which is going to give you 0.01, but that's not a percentage. To get the percentage back, you then have to multiply by 100. So
Okay.
it's the same either way, and that's why we don't even need to. That's the advantage of using this dilution formula, is we don't even need to convert out of those percentage units. Okay, but good point. Any other questions? And before we do this, we go back here. We see two quantities separated by the word of up here. Two quantities separated by the word of means we are going to multiply them together, and that's exactly what we wound up doing as we multiplied those together. Okay, so use the context of how things are worded to help you out. So in this one here, what volume of 6.0 molar potassium carbonate is needed to prepare 500.0 milliliters of 0.50 molar potassium carbonate? Part 2 for this question reads, assuming the volumes are additive, what volume of water is needed? So this one here is our dilution formula. Once again, we're diluting, we have a solution concentration, we're diluting it down, so we have C1V1 is equal to C2V2. In this case, we're looking for what volume? We're looking for V1, right? Okay, and that means that the 500 milliliters must be V2. And then we have two concentrations given. We have 6 molar and 0.50 molar. The 6 molar must be C1, and the 0.50 molar must be C2. And this should be pretty straightforward because we have two quantities separated by the word of. Remember, if they're separated by the word of, that means we will be multiplying them together. C2 times V2, right here, is equal to C1 times V1 up there. So if we're solving for V1, that means we're going to divide each side by C1. Once we divide each side by C1, we can then substitute in our values. C2 is 0.50 molar potassium carbonate. V2 is 500.0 milliliters. And then we divide this by C1, which we said was 6.0 molar potassium carbonate. Once we get to this point, what happens? Units are going to cancel, and the units specifically of molarity will cancel out. And then we take 0.5. We multiply it by 500, and then we divide it by 6. And we get 41.66666, etc. How many sig figs should be in the answer?
2.
2. So then we round it off to
42.
42, the label milliliters. So we have 42 milliliters as the solution. Any questions on this one? Okay, once we get this, then part B was, assuming the volumes are additive, What volume of water is needed? Well, this one should be relatively easy. What's the total volume we need? 500. And 42 milliliters of that would be this solution. So how would we find the amount that remains? We subtract. So we take 500 milliliters minus 42 milliliters. We wind up with an answer of 458 milliliters of water. And so again, assuming that they're additive, the 458 and the 42 should add up to give us the 500 milliliters of solution.